So, hello everyone, and welcome to Ask AuxEn Anything, our weekly online session that we conduct on YouTube, where we take the questions and interact with civil structural engineers regarding their queries related to any steel design or RCC design concept or any project that they are doing or construction and site issues. So, this is the 52nd such episode that we are conducting, and let us begin today's session by taking the queries that have been put in the by taking today's queries. So first we will take up the queries from Google form, and then we will take up the queries from uh, comments and other mediums. Okay, so let us start, and let me just open this OneNote. So I'll just share my screen, and let me open this. Yeah, so I hope the OneNote is visible. And let us take the first query, Mr. Alek Katuwal from Kathmandu, Nepal. He is asking, while connecting columns with shear wall, the column fails. While connecting column with shear walls, the column fails. What is the reason and possible solutions? I have attached supporting picture. So he has provided one email also, and on email he has provided this figure. So it's a screenshot from ETABS model. Yeah. So if you see, the walls have been modeled over here. I hope this is visible. So this is the RCC structural wall that has been modeled, and these are the columns that have been modeled, and the columns seem to be failing. And he is asking why this is happening. What is the reason for this kind of a failure? Just hold on. So first of all, this is an incorrect way of modeling, in my opinion, because unnecessary the columns have been modeled at the ends of shear wall. This sort of modeling is not required. Modeling like this is incorrect, in my opinion. uh, if you have provided these walls, what are these columns doing basically? These columns are not helping you in any manner, because anyway, when you model a wall, at the ends we always provide, or we always detail it in the form of boundary elements. So always at the ends we detail the boundary elements. Now, here what you have done is that you have introduced columns with walls. So first of all, how they are interacting, how the column and wall is interacting together, that you need to investigate, whether this column is failing in bending moment or this column is failing under shear. That sort of thing you need to first check what exactly is happening with these columns. Okay, one of the possibilities is that this wall or these walls may be attracting shears, and those shears are getting transferred to the column. So there might be failures in the column due to shear. Other reason can be that because this wall is will be having large in plane moments, much of the compression and tension is going to these columns. Okay, being on the boundaries, so these columns may be having a very large compression force under the effect of seismic load combinations. Now please remember that when we design these boundary elements in a normal RCC structural wall, the design of those boundary elements is done as short columns. So that means at the ends of these walls where we provide boundary elements, the design is done as short columns. That means we do not consider additional effects of slenderness over there, or we don't take into account, let's say, the effective length factor, or we will not take into account any additional moment magnification, etc. Now what might be happening in your model right now over here is that because you have modeled them as line elements column, the moments being taken are high because they are ends at the ends of shear wall. So there is a large concentration of in plane moment. and that might be getting converted to, let's say, compression tension couple in the column. Now for that compression, what ETABS will do is ETABS will start designing these columns like a normal uh, line member, like a normal column. So it will consider additional effects of slenderness, it will consider additional effects of minimum eccentricity, etc. So that is the reason why this type of modeling is not required. You should not do it. Okay. So instead, my suggestion would be just delete these columns and let there be only these boundary wall. Sorry, let there be only these shear walls, and just delete these columns from here. Okay, delete it. All right. So this was Mr. Alek with his query. Now we move on to the next query, and that has been the next query is uh, I think this query, did we take it or not? I'm not able to remember. I'm unable to remember whether we took this query, so I'll just take it again, because last week we did not have a episode. So he has these queries, Mr. Rajendra Kamble from Maharashtra, from Sangli, Maharashtra. He is a working professional, and he has the following queries. Any reference or guidelines for permissible limits of chloride, sulfates, and gypsum in soil and water? About ACI code, I am not sure at this moment. In IS code, they have given you the limits of chlorides and sulfates dissolved in soil or dissolved in soil water. So you can have a look at that. IS 4, even IS 456 gives you those limits. Gypsum, I don't think it's a problem for concrete as such, because your what should I say? Your concrete itself, the cement concrete itself contains gypsum, right? So I don't think gypsum is a problem. For chlorides and sulfates, they have given you the limits in the IS 456, so you can refer to that. How to fix number of boreholes and trial pit? This number of boreholes, there is a IS code for it, although I'm not able to remember at this point. uh, Number of boreholes, how to fix that? I think in they have given some in 10,000 some area. You need to perform 4 or 5. So if you strictly follow the codal provisions, you may need around 4 or 5 boreholes in a very small plot size, so which is not feasible actually. So generally what we do is we will in a general project we may take 1 or 2 at the max, because then cost wise it becomes prohibitive. If you start paying 30,000, let's say, for one borehole soil investigation, and if you had to do 5, nobody is going to pay 1.5 lakhs for soil investigation. So generally it is uh, it is not done as per the codal guidelines. Generally you may do 1 or 2 at the max. So that is how you decide the number of boreholes. But if you want to go code wise, there is a code for it, although I am forgetting its number right now. Maybe online you can easily get it. Then how to decide the borehole depth? This will depend on the type of structure. Okay, this will depend on the type of structure, what type of structure you are having, and what is the column load on it that you expect. So basically what happens is that, for example, this is my footing that I am placing. Now there is a pressure bulb theory, isn't it? There is a pressure bulb theory, that pressure below is distributed in a pressure bulb. So what the geotechnical person may ask you, that what is the expected column load. So a good geotechnical consultant will always ask you that what is the expected column load, what is the height of building, and what is the expected column load over there. So depending on that, for, let's say, for smaller column loads, the pressure bulb will be smaller, and for larger column loads, the pressure bulb will have a larger area, isn't it? So if your column load is small, maybe you need to go. your soil exploration depth may be only limited till here. But if your soil load, sorry, column load is greater, what may happen that its pressure bulb form will be such that you may require even larger depths. So typically, this how much depth of your borehole should be, that is usually decided by the expected column loads. But generally, I have seen that around 6 to 8 meters is what your borehole depths the geotechnical consultant tried to take for normal structures. They will try to take it up till uh, 6 to 8 meters around. And for if you were to require, let's say, deep foundations like piles, etc., then they may have to go to even larger depths. Then it's a different scenario. But usually 6 to 8 meters is what they try and go to. Okay. So this was this query. Then next question is from engineer Akash Babar. He is a working professional from Sangli again. And uh, what is his question? Please explain detailing of reinforcement at junction of ring beam, vertical tank wall, and horizontal base slab. No, but this is not clear exactly where do we want junction of ring beam. Where have you given the ring beam and how it is getting connected with vertical tank wall? Question is not clear. Maybe you may. I request you to provide some pictures or some drawing where you have mentioned where is the ring beam, where is the tank wall, where is the base slab. Then we may be able to discuss this further because this question is not very clear to me right now. Need some guidance on calculation of impulsive time period. So you may refer to IS 1893, the old IS 1893 part 2, which gives you the calculations for liquid retaining, sorry, which gives you the, okay, wait a minute. There are some comments. Mr. Rakesh Kumar is informing us that IS 1892 is the code for number of boreholes. Thank you. So, Mr. Rajan, you may refer to this IS 1892 for borehole numbers. Then Mr. Akash is informing regarding this query. Circular ring beam below wall, 8 columns connected by ring wall. Okay, so I think what he is providing is something like this, that he has a wall like this. This is in plan, and below this he has provided a circular ring beam all around peripheral. Just pardon my drawing. And in cross section it will look something like this, that he has got this wall, and I guess below this is his ring beam. How that ring beam is supported, I am not sure. Where it is getting supported, I'm not sure. And then from here, I think they are taking some columns above. 8 columns connected by ring wall. It's not quite clear, so if you could provide some pictures, etc. Okay, provide some pictures, then we will take your query. All right. Uh, in the meanwhile, he is providing some images or pictures. Let me take next question. So next query is from engineer Ketan Mahajan. He is a working professional and he has asked this, and he has provided a drawing also. So let me just show you that drawing also which he has shared. Where is it? So here I shared one PDF where the old plans are given, and let me just try to first open that PDF. So let me just open one PDF, sorry, one floor plan just for discussion purpose. So this is one of the, so in the PDF there are multiple floor plans, but I am just showing you one floor plan right now. And the question is that where a building frame structure is designed and executed as per residential building, right now the building is standing with its frame structure plus brick masonry of outer walls only, G plus, so it's a G plus 5 structure. So this was an old structure being designed as a residential apartment building, and now it has been purchased by a doctor who wants to convert it into a hospital. So the whole building is needed to be reanalyzed and designed and get retrofitted. Please share the design procedure. So design procedure will be simple. First you do some. So you already have the as-built drawings. So that part is done. Now you do the visual inspection. Okay. How old is it? I don't know how many years old it is. So you do some visual inspection. You try to see what is the condition of your structure, what is the condition of existing structure. You just try to investigate that by visual investigation, inspection, investigate the condition. So it can be said as a conditional condition assessment survey. If the condition is good, if visually you can see the column beams, there are no visible cracks, no visible spalling, no visible corrosion, and the structure is looking robust and strong, then you may not require to do anything further. But if by visual inspection you are seeing a lot of cracking, a lot of uh, signs of distress, then you may have to go for, let's say, some sort of an NDT. Okay, so in NDT you can do some core sampling just to see the strength of concrete and to find out the reinforcement condition. You can do a UPV test, pulse velocity, ultrasound pulse velocity test. So using the UPV on existing RCC frame, you can get to know the condition of your reinforcement. So for you may also from there you may be able to see the number of bars and their condition. So do these two tests through NDT. Once you have those results, let's say, then you go and prepare model. So I'm assuming that you'll use some sort of computer software like ETABS or STAT. So prepare model as per as built configuration. So whatever is the as built, according to the as built drawing that you have, you just prepare one complete model. Okay, and then new loads, apply the loads that are now expected because you have converted into a hospital structure. So apply the new loads now expected. Generally, the live loads will increase. More increase will be in the zones where you are going to put up, let's say, X-ray machines or MRIs or all sorts of machinery where you are going to put. There, the live load values will be higher. Otherwise, live load values won't be so much. So you need to look at the architectural plan that has been provided for the new structure, and then okay, 1 year old. It was never completed. Oh, only frame structure is standing. So then your problems are not that much. If it is only 1 year old, maybe you may not require to go for NDT testing because 1 year is not a big time. So this might not be required. Okay, just do a visual inspection and see, then apply the loads that are now expected. And after this, wherever you need, let's say wherever there is a shortfall. So short by shortfall, I mean that if let's say your columns are requiring more reinforcement percentage now, and because of the increased loads, let's say column requires 2% now, and your earlier provided reinforcement percentage is 1.2 or 1.1%, then you may have to go for some sort of retrofitting. So now what can be the retrofitting strategies? So retrofitting strategies for slabs. Now for slabs, it is slightly tricky. Retrofitting strategy for slabs will be slightly tricky because if reinforcement is insufficient, in my opinion, slab reinforcement will come out to be okay, because even if you are providing, let's say, 10 at 150 both ways, it is more than sufficient to take large amounts of live load. So I think slabs will be okay for you. If beams need retrofitting, then you may use the jacketing concept. So you may have to put additional reinforcement, and then follow it up by jacketing with concrete, micro concrete, mixed with some polymer, etc. Or the other way could be to provide some steel structural frame. Let's say provide a frame made of steel angles, etc. For columns, again, same. Either go for jacketing, I mean, provide additional reinforcement and then jacket it up with micro concrete or polymer mixed concrete, or again you may go for some steel framing and put that steel framing around the column. Now, if footings are problem, that means if footings need resizing, there is a possibility that your footings may also require increased sizing. Then it becomes tricky because then you will have to excavate and then increase the footing size. So over here, one of the ways could be that let's say this is the existing footing. First of all, you will have to excavate, and one of the options is, if possible, you may increase the plan area in this manner. That means by rewiring over here, but this is practically difficult to do. So the other option generally that is suggested in case of footings is, let's say you just fill this area up with PCC, some sort of plumb concrete, and the new required area, whatever you require, you just provide it on the top like this. So this becomes your new footing size. Okay, so this was my old, and this is, let's say, plumb concrete that you have filled up, and now this is the new size. And for here you may do some rebarring with the column, and use some shear transfers, something like dowels, so that your column loads are properly transferred to the footing. So this type of strategy you can apply for footings. So these are the options, or this is the short process that you may have to follow. This drawing does not look like 1 year old. I don't know. This looks like an old drawing. You are saying it's 1 year old, but it looks quite a old drawing. It has been hand sketch. I mean, this is a hand sketch. They have hand drafted it. So you are saying it's 1 year, but I'm not sure if it is 1 year. Then his next question was that in many of the cases, even for a ratio of the slab long span to short span ratio, even of 1.5, they have provided only one way reinforcement instead of two. So what he is saying is that, let's say, this slab panel. Now here, if you were to check for the Ly upon Lx, the Ly upon Lx, even at 1.5 ratio, they have provided only one way type of reinforcement. So see, if you look at SP24, they have given this explanation behind the one way, two way, And in the SP24, if you look at the ratio beyond which most of the loads are taken by short span, yeah, it comes to around 1.5. So basically, at around 1.5 Ly by Lx ratio, your short span will take almost 86 to 87% of the load. All right. I'm saying if you read SP24, in that SP24 or SP16, I think you read SP16. You go to SP16, and in that they have given the slab. In the slab chapter, if you see, even at an Ly upon Lx ratio of around 1.5, the short span takes almost 86 to 87% of the loads. So therefore, many old engineers, they may use this practice that even at 1.5 ratio, they just provide one-way type of reinforcement, and in the other direction they will provide distribution along the long span. So I think that's why they are doing it. uh, why does the code recommend you to just to add another layer of safety, not safety I would say. At around 1.5, the ratio of loads being taken by short span was around 86. So yeah, he is providing the correct answer. Long span takes 14% and short span takes around 86%. Correct. So I think this happens at around Ly by Lx of 1.5. Maybe that is the reason why your engineers are doing this way. So the code, instead of giving you 1.5, it gives you 2, but it's okay. Even at 1.5, largely the behavior will be along the short span. Image has been sent over email. Which image? Image. Acha, this image, SP16 image. Yeah, I know the image. I remember it. I remember it. I remember studying it. Okay. So then, what is this query next? As we want to convert it to hospital, the floor live load will also be approximately double. I don't think it will be double. Even if it was a residential, yeah, it will be double from 2.5 to 5. But in my opinion, it will not be a problem because see, the slab reinforcement is around, as per your sketch, the slab reinforcement is 10 at 150, and the slab thicknesses are around 6 inches, 4.5 inches, 6 inches. If you check it, even for a live load of around 4 to 5 kilonewton per meter square, I think the slab will be okay. You will see that slab will be okay. All right. All right. So this was his query. Then there is one query that has been asked on WhatsApp. So let me take it. This question has been asked by Mr. Weber. So he's saying, he has shared this image, and I am currently designing a sloping RCC roof, and I have a query related to ridge beam provision. Could you please guide me on the conditions under which a ridge beam is required? Is a ridge beam mandatory on all sloping roof systems, or does it depend on span and support? Yes, obviously it will depend on span and support condition, but it is always good to have a ridge beam like this. You may have a ridge beam like this and then provide sloping slabs on either side, and maybe here also you have beams, whatever. Kindly suggest relevant code. There's only IS 456, the concrete design code. There cannot be code for everything. So you may just need to follow the basics of RCC concepts. So it's always good to have a ridge beam because then it will provide you a stiff element, and on that there will be these sloping slabs that can be supported. So in my opinion, it is good to have it. Good to have a ridge beam. And for detailing references, you may refer to SP34. Otherwise, there is no separate code which is required over here. All right. Okay. Then this was Engineer Weber with his query. Now the next query that has been asked is by Engineer Vineet. He's saying, so we are now taking the queries from the live comments. So Mr. Vineet is asking, hello sir, in my project I want to know how to detail the reinforcement if 900 by 900 column is reduced to 700 by 700, one of the corners as the same. So basically what he is asking is that, let's say this is his column in plan 900 by 900, and the upper column is getting reduced to 700 by 700. One corner is fixed. Let's say the top left corner was fixed. So now, yeah, am I visible again? Yeah, there was some issue with the internet suddenly. So is this going live or what? Hello? I think it is live. Back we are live, right? Yeah. So the question that we were taking was regarding this column, and so here the reinforcement arrangement, although we are not sure what sort of reinforcement arrangement he wants or that has been provided, but it is like this. So I'll just provide a general sense of what needs to be done in such cases. Okay. So let's say we have something like this. So the pink reinforcement is what you require in the 700 by 700. And so see some column, some reinforcement, this reinforcement you can continue uh, reinforcement from 900 by 900 can be continued in, let's say, this and this. Do you understand? So on one face, oh, screen is not visible. Well, I think the screen is visible. Can someone just confirm if they can see the screen? Quick yes, no, please. It is visible. Okay. So on these two faces, On these two faces, the reinforcement from 900 by 900 can be continued inside the 700 by 700. Okay, so that is clear. Now, what happens on, let's say, these two faces where there was a reduction happening? So, on these two faces now, the general logic that you have to apply is, now I show you a cross sectional view. So, let's say this is my 700 dimension and this is my 900 dimension. This edge remains straight. Okay, now the general uh, thing to be understood is, let's say, let's take this column, this reinforcement. Now if you are able to take this reinforcement and the code says that what, not more than 1 is to 6 should be the slope. So if you are able to maintain this slope over here, which is not steeper than 1 is to 6, so it may be 1 in 7, 1 in 8, 1 in 9, 1 in 10, but it cannot be 1 in 5 or 1 in 4. So any slope that is less steep than 1 is 6 is allowed. But in this case, because there is a 200 mm size reduction, this slope may come out to be more than 1 in 6, steeper than 1 in 6, because what will happen, to maintain a slope which is gentler than 1 in 6, you may require to start bending this reinforcement at a greater dimension from here. So that means at this location your reinforcement percentage reduces, which might not be very ideal. So in this case, this type of a bar joggle may not be the best way. Now, in such a case, therefore, what you may be required to do is that you just curtail this bar. That means you curtail this bar like this. So this bar, let's say we are talking about this bar, green bar. So this bar you curtail by giving sufficient development length. So ensure that sufficient development length is given beyond this face. Okay, you need to take your bar and ensure that sufficient LD is provided to this bar, and then the new bar that you are taking for the 700 by 700 column, you need to again ensure that sufficient LD is provided. Okay, and then it is best that you provide maybe closely spaced lateral ties over here to take care of this sort of a LD. So this arrangement may be required for these two faces where the reduction is happening. On the two other faces where there is no reduction happening, you may be able to just continue the bar as it is inside the 700 by 700. Okay, so this was engineer Vineet with his query. Uh, let's see what we have further. Mr. Ronak is asking, he's from Goa, he's a working professional. I want to design a large liquid retaining tank, uh, 20 meter by 40 meter. So his question is that any thumb rule, 20 meter by 40 meter with size about 20, with height about 4 meter height. So see, height is not much if you understand, and because you have taken the liquid retaining structure course, you'll understand that the wall behavior will be mostly like a uh, the wall behavior will be like a vertical cantilever if you see at the aspect ratios. All right, so these are all vertical cantilevers that you are having. So mostly the movements will be in vertical direction if you look at the cross section, because it is only 4 meter height and this is 20 meter, this is 40 meter. So because of the vertical cantilever, you just need to provide vertical bars mainly. Horizontal bars will not be So important in this case. Okay. But the problem will be with the raft when you go to do the raft, or when you, let's say, I don't know what your case is, whether this is on ground or underground, but the problem will be when it comes to raft design, and when it comes to, let's say, top slab design. So now you cannot have a top slab of 20-meter by 40-meter span. So you may have to provide over here some internal column grid. Now that internal column grid will help you to reduce the raft thickness also, and it will help you to provide, or it will help you to be able to support the top slab also. So walls are not as big a problem as your top slab and raft design is going to be. All right. And then you also need to additionally check for the uplifts because of such a large area. If and because it is Goa, then the water table will be pretty close to the ground. So uplift condition needs to be checked well, and because the bottom raft size is so much, you need to ensure that there is no uplift in empty tank condition. Okay. So check for these two things. In your case, wall design is not so very important, and as such I don't have any thumb rules. It is better that you carry out a design, check everything, and only then give your quotation, or only then give your suggestions to client. Don't do anything based on thumb rules over here. Okay. All right. So this was engineer Ronak with his query. Mr. Vineet is asking what will be the ideal place for the reduction. Okay, so I think he's asking with this. No, so don't go for that sloping thing. As I told you, don't go for that sloping thing. You just take this bar and develop it over here, and this blue bar for the 700 by 700 column, you just start from this, develop it inside the 900 and do it like this. Then he had asked, Mr. Vineet had asked one more query related to the seismic gap, and he had some buildings that he was doing. There was a cluster of, I think there was a large building, and then he had broken it down into different clusters or different portions. And as per the seismic requirements, the gap coming out was around 300 mm. So now seismic gap required, because of large area he had provided some sort of an expansion joint, and then that expansion joint also had to be checked for the seismic gap, and that gap came out to be 300 in his calculation. So he was asking what to do with such large gaps. So you cannot be expected to put some fillers over such a large width. So I have seen what they do is that in slabs they will just leave the slab. Let's say this was a column, I'm showing you the sectional view, and this is my slab and column, whatever. And over here again, this is the gap that you want to maintain. So now this 300 you cannot be expected to close it with some filler. So they just close it with, let's say I may provide some sort of an edge angle over here, some sort of an edge angle over here, and just cover it up with some checkered plate, let's say. Okay. So just cover it up with a checkered plate, this gap, and I have provided two edge angles on the beams where you have to maintain the gap, and just cover it up with a checkered plate, and that's it. You don't need to do anything else. So this can be one of the options, because in my opinion, filling filler for 300 wide will not be uh, a suggested way of doing it. So I think you can maybe think of something like this. Then uh, what further queries do we have? Mr. Magaj is asking, is there any precaution to be taken in using grade more than M70? I don't have working experience of I don't have working experience of high grade concrete, so I don't have an answer over here. What to do? What are the precautions? So maybe if you are adding GGBS, because generally for higher grade concretes you have to add GGBS. So you need to look at the crack control, because the heat of hydration I think will be more. So maybe you need to look into that. But other things I'm not very sure, because I have not worked on it. Mr. Magaj is asking, what are the assumptions for data center design? I mean, I don't know what are the assumptions for data center. I don't know. Assumptions? No assumptions. What assumptions? You take the loads, whatever are necessary. You take the wind loads, you take the seismic loads. Because data centers will have large floor loads, you design it for that. I don't know what assumptions are there. Mr. Rajesh Singh is asking, I am using R equal to 4, then beam resting on minor axis of shear wall, and one end of shear wall and other on beam. Does it should it be designed ductile or ordinary? I am using R equal to 4, then beam resting on minor axis of shear wall. So I think in plan view this is a shear wall and beam is resting like this, if I understand correctly, and one end on wall. Its question is not clear. Maybe you could provide some sketches for this. Then Mr. Magaj is asking, an RCC column, steel rafter is resting on top of RCC column. I want to design base plate at rafter and column junction. How to take tensile forces from software like ETABS? No, so ETABS will give you all kind of member forces. Where is the confusion you are having? ETABS will give you all sort of member forces. So you just check the member forces and take it up in your calculations. Then Mr. Magaj is asking, some consultants take surcharge pressure as 0.33 times 20 times 0.6. I don't know why do they take this 0.6 extra coefficient. I don't know. You need to ask the consultants. I'm not sure what is happening. So it has to be, as we understand, K into gamma soil into H. So Ka, either you take 0.33 or 0.5 whatever into gamma soil, you multiply by height. Now why they are reducing it by further 0.6? I'm not sure. You may have to ask them what's happening. What are their assumptions behind doing this? Okay. All right. So these were the queries that were put on the Google form, and we have also taken the queries from the live audience. So this is all the queries that we had for this episode. Okay, Mr. Akash Babar has provided this image on an email. So let us go back and take his question again. Okay, so it was an overhead water tank. So his query was how to detail. Let me just bring his question. Yeah, so this was his query. Please explain the detailing of reinforcement at the junction of ring beam. So this is his ring beam vertical tank. This is his vertical tank wall and horizontal base slab. So see in your ring beam, first of all you check the orientation of this ring beam. See whether it has to take any hoop stresses or not, because there is a possibility that the hoop stresses in the ring wall, due to the hoop stresses in the hoop tension in the ring wall, some element has to take the hoop tensions. So just check whether this orientation of beam is good, or possibly an orientation like this may be more beneficial. Just check that out, because remember this ring beam has to take both. That means it has to take the loads for gravity also, because this ring beam is supported on these 8 columns, as well as it has to take or resist the hook tension also. So first of all, just have a look whether the changing the orientation provides you any uh, where is it? Yeah. So when it comes to detailing, you just have to ensure how the what are the assumptions you are having. So let's say for ring beam, if you have designed it for hoop tension, you may require these tension bars, and these bars of your ring beam also need to take the bending forces. Then you will have to provide stirrups. Now at the wall and beam junction, because of your assumption, you may require to develop the reinforcement inside the ring beam. So check whether that is sufficient space you are having for detailing. For the horizontal reinforcement of the slab, you, even if you do not consider a fixed uh, or rigid support, let's say, it's okay if you just develop the bar. I mean, just take it to, let's say, LD by 3, and that would be fine. You don't really require a rigid connection between the horizontal slab and the ring beam. Okay, so it is fine even if you don't fully develop this bar inside your ring beam, the slab reinforcement bar. And for this cantilever, now it all depends. See, if this cantilever is at the same level, you may be tempted to provide a bar like this. But then what happens is that now you are getting development. Now you have provided adequate development to the horizontal slab bar. So you just check, then in that case, maybe don't provide any releases, etc., and just try to continue this bar. If you're continuing this bar for the cantilever, then do not provide any releases, etc., and just uh, have a rigid like connection over here. And for the wall, as I just told you, you need to develop this bar inside. And for the ring beam, whatever forces, there will be axial hook tensions and the flexural forces and shears, for which you need to provide the reinforcement. Okay, right. So this was his query. Then engineer Tamilarasan is asking, I have modeled two line elements of 200 of RHS 200 into 100 mm separated horizontally by clear distance of 100 mm for a cantilever beam of span 3.9 meter, and I have got deflection of 40 mm. In another model, I modeled single line element and assigned UPT section of two RHS 200 separated horizontally by clear distance of 100 mm, such that total width of beam is 200 mm and depth of 200 mm, and got deflection of 14 mm. No, no. So you must have made some mistake in assignment. Remember, when you are bringing it from UPT to stat, I mean, if you are bringing it from section wizard to stat, there is a possible problem between the section modulus values, because it gets interchanged sometimes. So you just first of all ensure that you have properly taken the section wizard values and brought it to stat first of all. Okay, you're saying your total. So let me show your plan view. So you're saying you have got two RHS and this is 100. This is 100 and separated by 100. So overall width of your built up section is 300, and it's a cantilever as you just said. It's a cantilever, right? Yeah, cantilever. 3.9 meter span. So it's very easy to check this cantilever by manual calculations. Why don't you check it with manual calculations? So if you were to see this cross section, your cross section looks like this, where these are your RHS 100 cross 200 cross 10. This width is 300 and this depth is 200. So you just check it for your cantilever deflection. I think the formula is 5WL4 upon, I don't remember the formula, 384 EI, I think. No, no, no. This is for simply supported. Whatever is the formula for cantilever subjected to UDL or point load, you have the span, you know the moment of inertia, you will find out the I value. So very easy, it will be just two times the I, let's call it as ZZ, it will be just two times the IZZ of your RHS member. So just use that I value and see manually what deflection you are getting. Okay. Using manual calculations, just check what deflection you are getting. From that you will get an idea that whether your normal stat assignment is working or your UPT calculation is working. Very easy to check. I am thinking because there is such a large difference, the mistake that you are committing is that while bringing it from UPT to stat, please note that uh, the section modulus values have to be interchanged by the user, because there is an axis reorientation that happens. So just check that. And because you are getting almost three times difference, I think that is what is happening. Okay. All right. So this was his query. So I think we have taken all the queries for the episode, and this is all what we have for this session then. So you can continue putting your queries. As you all know, the Google form remains the same. So once every week we conduct this kind of a live session, but the Google form is the same. So you can just put your queries. You can keep putting your queries throughout the week in this Google form, which I am just providing it in the live comments again. And if you want to connect us over WhatsApp, you can send us a message using this link. Mr. Vineet is asking, we have an RCC member of size 400 cross 1600. Should this be designed and detailed as a column or shear wall? Says the length to thickness ratio, width to depth ratio is 4. Yeah, so ideally, if you look at 13920 for a width to depth ratio of less than zero point 0.4, I think it has to be designed as a shear wall. So ideally, this size you need to design it as a shear wall if you go strictly as per the code. Okay, and I was telling you, if you want to connect with us on WhatsApp, this is the link. So you can just click on this link and connect with us on WhatsApp. So this is all what we had for this episode. Thank you very much for joining, and we will see you next weekend now. So until then, bye bye and have a good week ahead. Thank you so much.